Hey guys, welcome back to the channel. Today we are looking at a classic sorting algorithm, selection sort. It's simple, easy to follow, and a great way to understand the basics of sorting. Let's start by understanding how it works. Selection sort works by dividing the array into two parts, the sorted and the unsorted. In each step, it finds the minimum element from the unsorted portion and swaps it with the first unsorted element. The sorted part grows by one element after each iteration. It performs n-1 passes for an array of size n, since the last element naturally falls into the place. Time complexity is O(n) square and it uses constant space. Now that we know how it works, let's see it in action. So we have this unsorted array. Our first task is to find the minimum element. We start by comparing 5 with 3. Since 5 is greater, we move the pointer to 3. Then we compare 3 and 8, no swap needed, so we continue. Then 3 and 6, again no swap. Then 3 and 2. Since 3 is greater, we move the pointer to 2. So finally we compare 2 and 7. No swap is needed over here. At this point, we have identified the minimum element 2. So we swap it with the first unsorted element, that is 5. Now that we have placed 2 in its correct position, we move on to the next unsorted part of the array. Let's speed up things and watch how the remaining elements fall into the place. With each pass through the array, the unsorted portion shrinks and the sorted portion grows, helping us visualize how the algorithm slowly brings order to the array. It's like organizing a shuffled deck of cards, where every pass brings you closer to a nearly ordered hand. As the iteration continues, the number of comparisons decreases because the largest elements are getting pushed to the end of the array. Notice that we only need to run the algorithm n-1 passes, since after each pass, the largest unsorted element is in the correct position, leaving the last element already sorted. By the time we have gone through all the elements, we'll have the fully sorted array ready to use. So we are on to our final swap, that is 7 and 8. After this, we finally have the sorted array. Now let's look at how we can bring this logic to life with code. First, we determine the length of the array. Then we start a loop that runs from start to n-1. Inside this loop, we set minimum index equals to I, assuming the current element is the smallest. Next, we run another loop, j, to compare the current element with the rest of the array. If we find a smaller element, we update minimum index to that index. Once the inner loop ends, we swap the current element with the smallest one found. This places it in the correct position. This process repeats for each element, gradually sorting the array step by step. Now that we have walked through the code, let's dive into its time complexity next. Here's the time complexity graph for selection sort. The algorithm performs n-1 comparisons in the first pass, n-2 in the second, and so on. This results in a time complexity of O(n) square in both the average and the worst cases, making it inefficient for large datasets. And that concludes our look at selection sort. Thanks a lot for watching, guys. Hope you found this helpful. If you enjoyed this video, make sure to hit that like button and don't forget to subscribe. I'll see you in the next one. Until then, keep learning, keep coding. Thank you.